Hi, my name's Zach. I work on the ecosystem security team here at Atlassian, and today I'm here to talk to you about uplifting customer trust with Forge. So how does Forge help me, an app developer, create more trustworthy apps? Let's find out. So I'm going to talk about the ecosystem security program here at Atlassian, how it applies to the platform and the apps, a little bit about the Connect security model, because that'll help us contrast and understand the Forge security model, and then some tips for writing secure Forge apps. So the ecosystem security team mission is to build customer trust by empowering the Atlassian ecosystem to improve the security of our platforms, partners, and apps. So we definitely act as a team, Atlassian and the app authors that write apps on our platform, and it's a mission of trust that we're in together. So trust demands are increasing from users. Their understanding of security and requirements are growing every day, and they're making more demands for security. They want to know rightfully where their data is and how it's hosted, how it's secured. It's no longer acceptable to just say it's stored securely, don't worry about it. They want to know specifics. And finally, security is the #1 priority for Atlassian. So this includes the ecosystem and the apps within it. So we're a team, we build and run the platform, and you write the great apps that our customers invest trust in. So if you write a marketplace app, you'll be familiar with 3 of these programs that we run. The first is the vulnerability management program, where we raise AMS tickets to enforce Atlassian marketplace security vulnerabilities and their SLAs. This ensures that app authors are fixing vulnerabilities within the SLAs set by Atlassian. The second is the dynamic scanning project, where we scan for security issues within our apps and how they meet the security requirements set by Atlassian. So we have thousands and thousands of apps, so scanning them is a really good way to get the coverage to ensure the apps are meeting these security requirements. And finally, we have trust signals. So these are badges shown on Marketplace based on things like whether or not the app is enrolled in a bug bounty, the SLAs that the app is meeting or not meeting, and answers to security questionnaires. So if you looked at Marketplace today, you'd see that there's badges based on whether or not the app is a cloud security participant. With Forge, users won't see what type an app is. They'll just see what controls the app addresses or implements. So this is a great signal of trust to customers. So if an app has a badge, it's generally more trustworthy than an app that hasn't addressed or implemented any of these security controls. It can be a really good differentiator for users when they're picking an app. If an app has a badge versus one that doesn't, they'll generally go for the app that has the security badge. The important distinction here is the type of app isn't important. Users only care if it meets their demands, so what controls the app implements, not that it's built on Forge or Connect. And it's worth pointing out that some security controls or access will only be available to Forge apps due to the change in architecture. Egress is a really good example of this we'll talk about later. So how do we increase platform trust so we can get app authors to write great trustworthy apps? So ultimately the apps are trustworthy by users. So the first thing we do to make sure that the app platform is trustworthy and build developer trust is set expectations. So these are requirements from customers, compliance and security internally. We then identify and help build out security features. So these are features that help app authors make more secure apps. And these apply to all apps, all developers. So many of these in Forge, and we'll cover these later. And then finally, as you'd expect, we run and conduct security reviews and testing of internal components at every stage in the Atlassian software development lifecycle. So before we dive into Forge, it's worth a recap of the Connect security model. And this let us help compare Forge and Connect and what the change in hosting model gives. So as you may know, Connect apps are vendor hosted. So when a user interacts with an app, they interact with Atlassian's cloud, and they also interact with the app server that hosts the app. So this sort of trust trio is difficult to gain insights around apps, and it puts a lot of strict security requirements on vendors who are hosting the apps that they have to be met at all times. So if we broke down the tenets of app security, this is just a few of the important ones we identified internally. The app author in purple on the left here is responsible for many tenets of app security. There are a few shared responsibilities in the middle, And then there are a couple on the Atlassian side around the platform and Connect framework. So on the left, for app authors, they're responsible for things like authorization and authentication of requests, the app logic in the app itself, storing data within the app, abuse prevention for things like runaway apps, user identity, input validation for things coming into the apps, and then output encoding for anything the app produces. And the middle, shared between Atlassian and the app author, we have network security, logging, and runtime security. So logging is a good example of, there's a bunch of logging that Atlassian do on their side around the app. And then there's also logging that has to happen within the app for each app to give a really good picture of what the app is doing and what it has done. And then finally, we have the Connect framework, which apps use to build their apps on top of, and then the platform for orchestrating everything together. So quite a few tenets that have to be addressed by app authors. And then if we were to look at the Forge security model as a contrast. So what Forge does is it introduces an Atlassian hosted model for apps. So there's a pretty big shift in the hosting model over Connect, and it means we can solve many of these problems at the platform level. So we can push many of those responsibilities we saw on the left in purple onto the platform and ultimately help uplift user trust. Because if a user knows that, hey, app authentication, authorization is done the same for all Forge apps, then that's easier to get the control we spoke about earlier. There is a migration path. So see my presentation on using Connect and Forge together also at Dev Day 21. So if we looked at the server or hosting diagram we saw before, what changes is the app moves from being hosted by the app vendor or on the app server within that trusted Atlassian cloud. So users trust Atlassian and the cloud. That's where their data is stored. That's where the products are run that they interact with. And it reduces the operational burden on the app authors of running an app. So as an app author, you don't have to worry about running your own cloud, locking down ports, making sure the server's secure and patched. That's all kind of taken care of you if you just throw the app at Atlassian to host. So if we went back to the Connect, like shared responsibility diagram, and we saw how the tenants change with Forge. So recap, this is the Connect diagram. And then with Forge, a lot of these responsibilities move either shared or onto the Atlassian platform. So the responsibility for security is definitely still shared. Forge is not a silver bullet for security. It's not just going to magically solve things at the platform level. You still need to write secure apps. So you'll see that the tenants on the left, like input validation, output encoding, and app logic, still on app authors. And this is not a full version of the shared responsibility model, that it's available on the Atlassian documentation website publicly. And it will differ on capability. So if you're using things like Forge UI Kit or web triggers or custom UI, some of these will change just because things like authorization or authentication will change in the case of web triggers versus UI Kit. It is also a living document, it's worth pointing out. So it will change as Forge evolves and some of the requirements expand. So one thing we've also done is expand and help define the security model for Forge. And the way we do this is we set security principles to drive internal security design decisions. One really good example of this is requiring consent before impersonation in Forge. We've publicly documented these on Atlassian, and I'll share a link at the end. And they can be changed with enough consideration and analysis, but it helps us define what should happen by design and what shouldn't. We also have the shared responsibility model documented. And this is designed to provide a clear distinction of who does what to both Atlassian and also to app authors. And this is similar to like AWS's or Microsoft's shared responsibility model that you may have seen. And lastly, platform features. So if we can push common security problems onto the platform and solve it for 2,000 apps at a time, then we've made security easier for everyone and we've helped uplift security of the ecosystem, tying back into user trust. We'll talk more about the platform features soon. So an example excerpt of the Forge security principles. So these are available on the Atlassian documentation website. So Forge apps can run without interaction, but like that's okay by design. They can read and write all content depending on the scopes they have. But what they can't do by design is things like act as a user without consent, increase scopes without reapproval, or access user authentication information. So you couldn't write a Atlassian app, Atlassian Forge app that helps users manage their Atlassian password. That wouldn't be possible. So to show how Forge helps mitigate some common vulnerabilities, we're going to walk through a real example. So we know from the bug bounty data that Atlassian and marketplace partners collect that XSS, so cross-site scripting, is a fairly common vulnerability. And this is very reflective of all apps, all web apps. It's a very hard vulnerability class to address. So we can't solve this magically at the platform level, but what we can do with Forge is help add defense in depth controls. So if, for example, I had a Connect app that calls out to the Confluence API to grab the current user that's interacting with the app and displays their username in a page, it would look something like this. So if you've ever written a Connect app, you'd be familiar with API requests. So we call out the API to get the current user, grab their display name and shove it into the page. So fairly straightforward app. What happens if my name is a JavaScript payload? So you can see my full name is script alert and this is a perfectly valid name, just like taco is a valid name. What would happen in this case? So for the Connect app we just saw, we end up taking the full name and placing it into the DOM exactly as is. So you'd end up with this script payload in the browser. And when you run the app, you would see the web browser display this alert. So that cross-site scripting payload has fired. And this come from the Atlassian API and been displayed by the app without any output validation, output encoding, sorry. So to address XSS, like it's pretty standard AppSec guidance, but you should encode data before outputting it. In the SRM, that's still the app author's responsibility. And output encoding will depend on the context. So for example, in many apps, this is HTML because you're displaying it on a HTML page, but it might be SQL if you're taking that username and saving it to a SQL database. And don't trust user input. So that user input may come via Atlassian, but it still needs to be treated as untrusted input because the output encoding depends on the context very much. And the OWASP security cheat sheets have some really good guidance on addressing things like XSS that are worth checking out. So Forge has a capability called UIKit, which is a set of vetted standard components which are safe by default. So these take care of output encoding in many cases. And if you ever use React, it's extremely similar to that. So if we were to write the same app in UIKit, so Forge, we call the Confluence REST API again and add the username into the page, you would see that if we ran this, the payload is benign. So that username that's displayed into the DOM would be correctly output encoded and no XSS payload would fire. So Forge also offers a capability called custom UI, which is iframes that your apps can embed in our products to get the flexible UIs that you need. And one of the features is we take the Forge manifest permissions. So inside your Forge manifest, there'll be a permission section around content, which would describe how the content within the page can be run. And Forge uses this to create a content security policy that describes to browsers what on the page should be allowed to run and what shouldn't be. So for example, unsafe inline for styles would be okay. And this content security policy would be as good as your content permissions. So it's a really good defense and depth control. If we were to run the same app in custom UI, by default, the inline script would be prevented by the browser. So we've told the browser, don't allow inline scripts. So when we try and render that username in the page, nothing happens. The browser's prevented it. So it's a really good defense and depth control. In addition to the other escaping that you should be doing in your app. So Forge also offers security features. So we have storage, which has been a rather large missing thing from Connect. So many Connect apps use entity properties for storage, but Forge offers a storage service that lets you securely store app data with Atlassian. And then we also have egress controls. So this is really good for building customer trust, especially when that's surfaced on the marketplace, and defense in depth controls like vulnerabilities for server-side request forgery. So for example, if somehow your app makes a request to a server, if there's egress controls, the platform can ensure that the requests only go to the servers you intend it to, not to somewhere else on the internet. Logging is another really good example of a security feature, and there'll be more that come into Forge in future. So some tips for writing secure Forge apps. So in addition to the really good guidance on the Atlassian developer site and generic guidance from OWASP, I wanted to run through a few tips. Number one is only request permissions your app needs. So if you're running an app, for example, to leave Confluence comments on a page, don't request the manage permission scope. This will help increase user trust because they understand that if I have an app that leaves comments, it doesn't need the manage scope. So what is it doing if it does request that? And it's a really good defense in depth control against logic or app errors. So say you did have a bug in your app, but make sure that your app can't get more data than it needs to. And for Forge, we've also introduced granular scopes, and there'll be more coming soon, that allows apps to use the OWASP scopes over the Connect scopes. So as you know, in Connect, they're very broad, there's an admin read write, but in Forge, they're broken down a lot more. And Forge linting is a really good way that helps you identify which scopes you actually need. So as you introduce the API calls, Forge lint will tell you which scopes you need. The next is try and defer authorization to Atlassian. So the flexibility we offer in our products makes the authorization rules really difficult to replicate outside the products. So the guidance here is to use as user where possible over as app. And this means intersecting permissions, unlike connects impersonation, are applied. So for example, the scopes that the app has and the permissions that the user has are combined to restrict what the app can and can't do. And this helps you as an app author defer complex authorization rules to the products, e.g. Confluence or Jira. It's important to avoid as app where you can, because that may have more permissions than the interacting user. So for example, I'm a user that only has read, but your app requests write, and your app is now a vector for writing content into Confluence. And then leverage secure Forge variables for sensitive data. So they are encrypted, and it lets you set environment variables that go with the app that are encrypted, and keep your sensitive data out of source code, bash history, and logs, and other places like that. There's also Forge storage that helps you store customer data within Atlassian. And then lastly, consider the secure defaults of Forge. So we let you unwind some of the secure defaults in Forge for the flexibility you need to build great apps, but security is about lifting the bar to make exploitation more difficult. And a lot of these controls are defense in depth. So definitely consider the impact before changing any of the permissions, the content security policy, for example, because you're still responsible as an app author for the security within an app. And lastly, to recap on the Forge app shared responsibilities. The responsibility for security in Forge is still shared between Atlassian and you as an app author. So we have to work as a team to uplift the trust, so we can build a great platform. We can also build great, trustworthy apps on top of the platform. So thanks for coming to my Dev Day 21 talk. There's a link to the documentation I referenced at go to atlassian.com/forge-sec. And feel free to email me if you have any questions or comments at zsims@atlassian.com. Thanks.